So in lesson 3.3, they're talking about something called stochastic processes and trees. Stochastic, we've already talked about actually. They're just giving a name to it now. What we talked about was it's an experiment that consists of a sequence of sub-experiments. So all of these other small things are happening and it makes up this one big experiment. So one situation where that's one situation where that could happen is flipping a coin 3 times and noting the result of each flip. Well, flipping the coin 3 times are like 3 sub-experiments, and if you put all those together, that's one experiment. So that's a stochastic process. All right, so this first one that they're asking about, they said there's a box, and there's 2 boxes, I'm sorry. We're going to select a box, either box A or box B. Then we're going to select an urn. I wish they would have called that a bowl, but it's okay. And then they told me in box A, there's 3 different urns. There's A, B, and C. And then in box B, there's 2 different urns. They're going to call those D and E. And they want me to draw a tree diagram to kind of show how this goes. So we're going to start out, I don't know if you guys remember back, we always kind of started out with, okay, let's begin. From here, I'm going to pick either box A or box B, right? So my first sub-experiment is which box am I getting? Okay, then, let me see if there we go. My second situation, my second sub-experiment is picking one of those urns. So if I got box A, I have 3 choices for urns. So I've got urn A, urn B, or urn C, right? And then if I picked box B, I have 2 choices. I have either urn D or urn E. Okay, so there's my tree diagram. I've done that part. Now they're asking me to assign conditional probabilities to those. So then you just have to think about, like, what's the probability that each of these things is going to happen. So the probability that I would pick box A over box B is 1 chance out of 2, right? Because there's only 1 box A and there's 2 boxes total. So that means this one is also 1 out of 2. So total in this sub-experiment, that should equal 1. Okay, so same thing with the urns. If I got box A, then I have 3 choices for urns, and they were all equally likely to be chosen. So there's a third of a chance it could be that one, a third of a chance it could be that one, and a third of a chance it could be that one. So you just assign each of those a probability. Okay, the next one, there's only 2 of them here. So there's half a chance it could be this one, half a chance it could be that one. Okay, so what they're going to have us do in the end is figure out, okay, so what are all of my options over here? What are my possibilities? And then what is the probability of that event happening? So for instance, me choosing box A and then also choosing urn A means I had half a chance here and a third of a chance here. So I could multiply those out, and that would give me 1/2 times 1/3 is 1/6 of a chance. So I have a 1/6 of a chance of doing that specific event. Okay, so this one that's all they wanted me to do in that one. The next one that they gave me, example 3.13 in your book. So they drew some pictures for me. And when I go to put my probabilities in, I'm going to have to go back and look at the problem. So I'll just bring that in front of you. But they gave me this whole idea. They said, consider a 3-stage experiment which uses boxes, urns, and colored balls. So I have these. Here's box A. Here's box B. I have these urns. So just like in that last one. But within each of those, I have these colored balls. And I listed them as R's for red, W for white, and B for blue. So that's where all of those letters are coming in. Okay, so they want me to select a box, then select an urn, then select a ball, and note the color of the ball. And they said, suppose all selections are random. So none of them are weighted more than the other. This is actually not the one I'm going to have to go back and look at the problem on. So this should be a pretty cut and dry one. All right, so I'm going to begin. And I'm going to start out with, I'm either picking box A or I'm picking box B. And I'm just going to give myself lots of space there to make sure I can fit all of this in. Okay, from there, in box A, I had earn A, B, and C, and I had earn D and E in box B. So I'm going to go ahead and write those out just like the last problem. So I have A or B or C for my earns, and then on this one I had D or E. All right, within earn A, I have 3 balls. 2 of them, though, are red. So you have to be careful with, I don't really care how many red ones I have. When I'm just making my tree diagram, all I know is that I have either a red one or a white one. That's it. So I don't care. I wouldn't put red, red, white, because red, it doesn't matter which one I get, it's still a red ball. So I will deal with that when I deal with my probability right here. So I have 2/3 of a chance of getting red and only 1/3 of getting white. So we'll talk about that once we get there. The earn B, I have 3 red and 1 white. So again, all I have to worry about is either red or white. In earn C, same thing. I only have red or white. Okay, in earn D and E, I have, in this one, I have red, blue, and white. So I'm going to list those out. I've got red, I've got white, but I also have blue as an option for this one. And then in earn E, I have red, white, and blue. So I have the same 3 options again. So I'm going to list all 3 of them out. I've got red, I've got white, I've got blue. All right. So now I'm going to go back and look at my probabilities here. So my probability for box A and box B is the same as what we had in that last problem. I have 1/2 on each of those. That's the probability of getting them because there's only 2 boxes. All right, this one, I still had my 1/3, my 1/3, and my 1/3. Because there's 3 options there, this is 1 out of those 3. On this one, I have 2 options, so this is 1 out of 2. 1 out of 2. Okay, this is where it gets weird, right? So my red, I had in this earn, I had 2 red, 1 white. So I have 3 total, but 2 of them are red. So 2 out of 3 for red, which means I have 1 out of 3 for white. So even if they didn't tell me that, I could come up with that because I know that 3 out of 3 is the total. All right, for this one, I have 1, 2, 3 reds out of 4. So this one is 3 out of 4. And then this one would be 1 out of 4. In this one, I have 1 out of 3. So my whites are 2 out of 3. Okay, in bowl D, I have, let's see, 1 red out of 4. So this one is 1 out of 4. And I also have 1 white out of 4. 1 out of 4. And then my blues, I would have 2 out of 4, which I could just call that 1/2, right? So if you wanted, you could change this and say this is really 1/2. That might be easier to calculate later. So let's say, for instance, they want to know what the probability is of getting box B and earn D and then a blue ball. Well, that would be 1/2 times 1/2 times 1/2. Rather than doing 1/2 times 1/2 times 2/4 and then having to simplify it, you could just simplify it here instead. That's a little easier. All right, my last one. So I'm up here. It looks like I have 1, 2, 3 reds, 1 white, and 1 blue. So total I have 5. So 3 out of 5 are red, 1 out of 5 are white, and 1 out of 5 are blue. And again, make sure those add up. So these would add, that would add up to 5 out of 5. So that's good. Okay, and then in this particular problem, let's see, did they ask me problem, form a tree diagram and compute the probabilities for all outcomes. So they want me to go ahead and find the probability for each of these outcomes. So on this one, this is me saying, here's my outcome. I did a box A, earn A, and then a red ball. So that's 1/2 times 1/3 times 2/3. Well, that would be, multiply straight across, that'd be 2 on top out of 2 times 3 times 3. So that'd be 3 times 3 is 9, times 2 is 18, which gives me 1/9. Now what you could have done, so this is kind of how my brain works, I had a 2 on top right here, and I had a 2 on bottom right here. I would cancel those out and just say it's 1 times 1 and 3 times 3, which is 1/9. If you don't take that shortcut, just simplify later. It's no big deal. Okay, second possibility. I have box A. I have A. I forgot about this one. And then white for the ball. This was similar. This one was 1 times 1 times 1, which is 1, over 2 times 3 times 3, which is 18. So 1/18 for that one. The next one, if I had box A, earn B, red ball, I'm going to go ahead and write all these out. White, box A, earn C, red, A, C, white. And then I'll go back and do those other ones. Okay, so this one, box A was 1/2 times 1/3 times 3/4. So I would mark out the 3's in that case. So that gives me 1 on top, and 2 times 4 is 8. So I end up with 1/8. Now, if you didn't do that, if you just multiplied straight across, you would have gotten 3/24, but that simplifies to 1/8. This one, I've got 1/2 times 1/3 times 1/4. So that gives me 1 over 2 times 3 is 6 times 4 is 24. All right, this one, 1/2 times 1/3 times 1/3. So that's 1/18. And then this one, 1/2 times 1/3 times 2/3. Again, my 2's would cancel, so it's really just 1 over 9. You maybe could have gotten 2/18 first and then simplified it to 1/9. Okay, the next one, I've got box B, earn D, red, BD white, BD blue. And then the next one I would have BE red, BE white, and BE blue. Okay, so BD red would be 1/2 times 1/2 times 1/4. 2 times 2 times 4 would be 16. So this is 1/16. And then same thing for the next one. It's 1/4 also. So 1/2 times 1/2 times 1/4 is still 1/16. The next one I have 1/2 times 1/2 times 1/2. Or I could have said 2/4, sorry. So that would give me 1/8. And then the next one, I've got 1/2 times 1/2 times 3/5. So that would be 3. And then 2 times 2 times 5 would be 20. And then this one would be 1/2 times 1/2 times 1/5. That's 1/20. And then this one would be the same, 1/20. So there's all my probabilities. These right here are those probabilities they're asking about. So what they would have you do is, typically in your problems, they will say, what's the probability of picking box A and getting a red ball? Well, if you pick box A and you get a red ball, that means it's one of those 3 cases. So what you would have to do is add up this one and this one and this one. So 1/9 plus 1/8 plus 1/18. If you don't have a calculator, you'd have to get a common denominator and add those together. If you do have a calculator, just type them in and get your total. So make sure that you're ready for situations like that. Okay, example 3.14 of this, that's exactly what they're doing in example 3.14. So let me show you that. They said, okay, look back at your example 3.13, which we just did. And they said, find the probabilities of these events. The first one is a red ball is drawn. Okay, well, if a red ball is drawn, I'm doing the probability that red happened, right? And it doesn't matter what box or what urn was chosen. I just need red. So I would go through in my possibilities over here and find anything with red. Okay, so that would be in this case a 1/9. I'm going to write these out here. 1/9 plus I've got a 1/8 right here plus a 1/18. Let me zoom out so that you can see maybe what I'm talking about here. There we go. Plus this one, I've got a 1/16 plus I've got a 3/20. And if I use a calculator and add all of those up, I end up with 121 over 240. I'm assuming you do not want to do that by hand. So if you don't, use a calculator. And I am okay with you using a calculator on this lesson for sure. Okay, this one, what's the probability of a white ball being drawn? So probability of a white ball. Okay, so I'm going to do the exact same thing. I'm going to go back through these and add them up. So white here was 1/18 plus white there was 1/24 plus white here was 1/9 plus this one is 1/16 plus this one is 1/20. And again, if you add all of those up, you should end up with 77 over 240. Okay, last one, probability of blue. So the good thing about blue is there's none up here because blue wasn't an option in box A. So the only place where we have to worry about it is right here and right here, blue and blue. So 1/8 plus 1/20. And again, you'd have to get a common denominator. This one ends up 42 over 240 is what they got. Now let's see if these simplify. This one definitely does. They didn't simplify any of theirs. Especially ahead of time, they didn't. So 121 over 240 does not simplify. 77 over 240 does not simplify. But this one, 42 over 240, that is the same thing as 7 over 40. So I would love it if you would write all of your answers as simple as possible, especially if you're using a calculator. It's going to do that for you anyway. Okay, so this one, I wanted to kind of point this one out real quick. This next problem, this example 3.15, they gave some pretty specifics for your probabilities over there. So this one was talking about, let's see right here, if they are uptown and 1, 2, or 3 comes up, they see movie A. So make sure when you're looking at your probabilities, you deal with that. Maybe take a look at this example when you're doing your problems, because that one gets kind of complicated, but I'm going to leave that one just for time reasons. I'm going to leave that one off here. So I'm going to skip over to problem 3.16. So 3.16 says this: I have a high jumper that practices with a bar at a specific height. She attempts until she has 2 consecutive successes or 2 consecutive misses, or a total of 4 attempts. And the coach records the result of each attempt. Suppose the probability that she clears the bar on any attempt is 0.6. So no matter what, that's 0.6, which means the probability that she does not clear the bar is definitely always going to be 0.4. Okay, so over here, the problem says, view the results of one sequence of attempts as an outcome of an experiment, and let the event E consist of those outcomes in which she clears the bar exactly twice. So exactly twice, I'm trying to find that probability. Okay, so they did their tree diagram. I'm not going to recreate it. I'm just going to show you guys theirs. So here's their tree diagram. They said, here's where I'm beginning. This is a success, and this is an unsuccessful attempt. I probably would have called it like cleared and not cleared or something like that, but it doesn't matter. Okay, so the probability that she had a success was 0.6. So the probability that she did not do it successfully is 0.4. Now, off of each of those, so let's say she gets a success the first time, she could get a success the next time or a failure again, right? So they did the exact same thing, 0.6 and 0.4. There they stopped because in the problem, they said she either does 2 consecutive successes, 2 consecutive that are not successful, or she does 4 attempts total. So they stopped on this one because she had 2 successes. This one she had to keep going. This one she had 2 unsuccessful attempts in a row, so they stopped there. This one was not 2 in a row, so she kept going. That was the 4th one though, so they stopped right there. Okay, so pay attention to those types of things. Then when they found their probabilities, they did these as decimals, so they came up with their probabilities in decimals. You could have done it as a fraction. So you could have said this is 6/10 or 3/5, and that is 4/10 or 2/5, and went from there. It doesn't matter to me which way you get your answer. Okay, and then they wanted to know what's the probability of her getting exactly 2 successes, right? So 2 successes here, that would have to be counted. This one would not because that was 3 successes. This one is 2, so that counts. This one is 2, that one counts. This one is 2, so it counts, and that's it. So they took those that I just mentioned, these 4, and they added them up, and they got that final answer. Okay, if you have any questions, though, in class, I can definitely answer them. I just wanted to make sure I gave you lots of heads up on this one because it's going to be kind of a shorter time period before you take the quiz over this. All right,